Newton's laws of motion. Act like you are riding in a tricycle. When the tricycle starts moving forward, how will your body behave? When the tricycle suddenly moves forward, the passenger will move backward. That is because of the law of motion. What are the laws of motion? Let's find out. Sir Isaac Newton, an English scientist and mathematician famous for his discovery of the law of gravity, also discovered the 3 laws of motion. Today these laws are known as Newton's laws of motion and describe the motion of all objects on the scale we experience in our everyday lives. Newton's first law of motion, also known as law of inertia. Newton's first law of motion is often stated as, an object at rest tends to stay at rest, and an object in motion tends to stay in motion with the same speed and in the same direction, unless acted upon by an external net force. Newton's first law talks about the tendency of a body to remain in its present state of motion. There are 2 states of motion that is mentioned in the first law, one which predicts the behavior of stationary objects and the other which predicts the behavior of moving objects. Inertia is caused because objects have mass. The more mass an object has, the more inertia. Newton's first law talks about the tendency of a body to try to resist changes its state of motion. This tendency to resist changes in its state of motion is described as inertia. Inertia is the property of an object that resists change in its state of motion. Examples of Newton's first law of motion. 1. Car suddenly stops and you strain against the seat belt. 2. Car turns left and you appear to slide to the right. In first law, unless acted upon by an unbalanced force, this golf ball would sit on the tee forever. Newton's second law. Newton's first law of motion describes what will happen to objects in the absence of an external net force. In Newton's second law pertains to behavior of objects if the forces are not balanced or if the external net force is not zero. Law of acceleration. The acceleration of an object is directly proportional to the magnitude of the net force acting on it and is inversely proportional to its mass. Force is measured by the multiplying the mass of an object to its acceleration. The acceleration of an object is dependent on 2 variables, the net force acting on the object and the mass of the object. The acceleration of an object depends directly in the net force acting on the object and inversely on the mass of the object. As the net force increases, so will the object's acceleration. However, as the mass of the object increases, its acceleration will decrease. Small force equals small acceleration. Large force equals large acceleration. Acceleration is inversely related to the mass of the object. In other words, using the same amount of force. If you double the mass, you double the force. If you double the acceleration, you double the force. What if you double the mass and the acceleration? Doubling the mass and the acceleration quadruples the force. Examples of Newton's second law. Riding your bicycle is a good example of this law of motion at work. Your bicycle is the mass. Your leg muscles pushing on the pedals of your bicycle is the force. A ball develops a certain amount of acceleration after being hit. Newton's third law. Action-reaction. Newton's third law of motion, also known as action-reaction. For every action there is an equal and opposite reaction. Rockets take off because a force downwards from the bottom makes them accelerate in the opposite direction. Properties of action and reaction pair forces. 1. Action and reaction forces always come in pairs. 2. Action and reaction forces are equal in magnitude but opposite in direction. 3. Action and reaction forces act on 2 different bodies. 4. Action and reaction forces have the same line of action. Examples of Newton's third law of motion. 1. Hitting a ball. Action force bat hits ball. Reaction force ball hits ball. We exert an amount of force against the ball with the bat, which in reaction exert the same force on the wood. This is why the bat can break while the balls are thrown. 2. Deflating balloon. Action force air inside the balloon rushes down. Reaction force, the balloon moves upward. The air inside rushes down and the balloon moves upward. In this situation, the action is by the balloon that pushes the air out of it when setting free. The reaction of the air which escapes out from the balloon acts on the object.